Hi guys, welcome to Learning Electronics Repair and part 2 of Salvage Weekend. So we have some more circuit boards and things we can salvage some parts from today. I'd just like to mention, I think there's a few good reasons why we should do this, apart from getting components for free, of course. So the first one really is that doing this will enhance your soldering skills. You're hopefully seeing part 1, you've seen the way I've been removing components. We're going to do more of that today. So if you can't remove components like you've seen me doing, then either you just need more practice or your soldering equipment isn't good enough. So not only by salvaging components will you hone your desoldering skills, and by doing so you will also hone your soldering skills. You'll also just get the feel for how solder handles itself, how it works when it's molten, and you'll find out how good your equipment is. If you can't do this, then the chances are you have the wrong sort of solder, the wrong sort of flux, the wrong sort of soldering iron, the wrong sort of tip. So this is a perfect opportunity to try different soldering tips, for example, to see what works for you. And what works for you may not be what works best for me, because we all have our own slightly different ways of doing this, or completely different ways of doing this. You'll also learn the limitations of your equipment. How good is your hot air station? How good is your soldering iron? What can it handle? What can't it handle? It'll give you a much better idea of the limitations. And maybe you want to buy some other equipment and try that as well to see if that helps you to do this sort of thing better, okay? Another great thing with this is you will get better at identifying components, especially if you're fairly new to this. This will help you to identify components. You can look at them with your multimeter or other equipment, maybe a component analyzer, as I was using in part 1. So yes, this will help you to identify components. You'll probably spot some faulty components as well, visibly faulty. And this will help you also to identify those components when, for example, you are repairing something. And another important reason is this should be fun. If you don't enjoy this, then electronics as a hobby probably isn't for you. Maybe as a career, but between a career and a hobby, they're not quite the same things. So if you enjoy doing this sort of thing, then electronics on the whole as a hobby will definitely suit you. Okay, so let's carry on. I have a few more boards to look at. Let's see what else we can salvage. How about this one? What would I take from here? Well, clearly I'm going to have these large transistors off this. I'm going to have these as well. I will probably have the high voltage capacitor because I don't really have many of these. Okay, and these large wire wound resistors are definitely worth having. There's a few more transistors on this one. So again, this is going to be, to a fair extent, depending on how easy it is to remove the parts. Okay, let's go with these transistors first. So I've added solder. Just try to get a hold of this one. Yeah, you can see that's coming out quite nicely. Okay, what is that thing? 2SA194S. No, 1943. Okay, probably quite handy. I may find these are complementary, so yeah, look, you see these are 2SC. SC 5200. These are really quite handy transistors, yeah. The complementary pairs. Okay. Yeah, legs slightly bent, a little bit short, but we can use these. if you like, hold this in a clamp or something. Of course, I don't know if these transistors are good or not. As I say, I would normally put them into my stash and test them if I want to use them, but we can check these actually, because they're such nice transistors. It'd be interesting to see if we have good ones, because these are scrap boards. They're scrapped for some reason or other. Okay, let's keep going. So some sort of 3-pin device here. This should be quite easy to get. Once more, add a bit of fresh leaded solder, makes life easy. Look, I've managed to bridge all the pins, that makes it even easier. This is getting quite warm, so I'm going to put something through the hole. Okay. And do it that way. Whatever that device is. Same with the one next to it. This is the one where I'm going to have this high voltage capacitor as well, 2 kV. Quite often high voltage components and high wattage components I will salvage. Again, it's getting hot, so just stick something through the hole. Do it that way. Again, not totally sure what. Oh, A something, yeah, maybe a 2SA940. Another one of these ones. And then these large power resistors, easy again, we can just prop something into the gap between the leg and the body. Out it comes. Other end. Yeah, clean. Decent length legs on that. 0.5 watt, very useful. Same trick with these small transistors. I'm actually going to just get the tweezers between the legs basically into the gap between the body and the board, and then they should just fairly easily just desolder. Yeah, see, it came out. Same again. Okay, I actually had 2 of those boards. One had the power resistors already removed. The other one was complete basically. So what did we get? Well, we have 4 of these 2SA1015. We have a whole load of these 649 and 669A. I'm fairly sure we can say these are complementary transistors. We'll have a quick look. We have 2 of these high voltage capacitors, very handy things. We have 4 of these, are they all the same? C2073 and A. Yeah, so these will be complementary pairs again. And then the same with these power transistors. We know we have some 2SA and some 2SC here, okay? And lastly, we have 4 of these power resistors. Quickest way to check these is with one of these component analyzers. Mine's falling to bits, but it works. So we can have a quick look. This one may actually be faulty. I said this was off a piece of faulty equipment. But also my battery's a little bit flat. No, it's a transistor, it's fine. Okay, so that's a PNP transistor. That is the, what is it? 2SA. So if we take one of the 2SC, this one, this should be NPN. So those are really useful transistors to use in a whole variety of projects. We've got probably a reasonable amount of money's worth there as well, and we can be confident these are original, genuine ones. And the same will apply to all these other devices as well. So this one, 669A, yeah, an NPN. So then the 649s you would assume will be PNP. Let's have a look at one. Yeah, PNP. So definitely a very nice stash there. So all bagged up together, that'll make those easy to sort out later. This is an old ATX power supply. It's not complete. You can see a chip's been removed here, one here, the transformer's been removed. This has been previously salvaged for parts, but now I'm going to take what else I want from this and then this can go in the bin. If you look at this one, you'll see these capacitors. See this one here, which is domed, that one, like they're bulged on top. If you compare with this one, which is flat, those domed ones are faulty. The flat ones of the same type and value may or may not be faulty. You could, if you want to have a look at one of these. So we can see here we have a flat one. You may want to remove that, but certainly test it. In fact, you can see that is actually a different capacitor to the other ones. But probably the electrolytics I will leave alone. I will just take that one, I think. We have on here some little trimmer pots, this one and this one. These are little variable resistors, but preset ones, they're nice. These capacitors if you want them. Fuse, definitely have the fuse. I think there's another fuse, yeah, I think that's a fuse there as well. Or it's a resistor under a piece of heat shrink, it says R something by it. These inductors, this one and this one, I will have. There's a higher powered resistor, maybe a 1 or 2 watt. So the small resistors I don't bother, but these higher powered resistors I will have. And then probably the 2 large bulk capacitors. This one, this is a high voltage capacitor, probably somewhere between 470 nanofarads to 1 microfarad. These fail in power supply switch mode. You pretty much always find these in an ATX supply. Definitely worth having. You can see another quite heavy resistor there, so we'll have that. And what else do we see? Big chunky diode. I'll take the big chunky ones, a couple more transistors, opto isolator, and then heat sinks. Heat sinks you should always salvage unless you happen to have hundreds of them already. These are expensive things to buy. They're very useful in projects. So let's get stuck in on this one. Let's see what we want from it and what's left afterwards. So as I mentioned first, a couple of these electrolytic capacitors I'll take off. So same technique we've been using all along really. Hit both ends, just waggle it out of the board. Okay, 2200, 10 volts, and the other bigger one. $2,216. Those are quite useful. These larger resistors certainly. Okay, quite long leads on these, so they're handy. That's a 47 ohm, 47 and 0 zeros. The black means 0 is more zeros. I saw another, yeah, this one. So I think this might be a resistor. So we'll have that. Just get this end out first, and then I can hold this while I remove the other leg. Saves burning my fingers holding that piece of wire. Yeah, out it came. What is that? We'll have a look in a minute. This one I'm certain is a fuse. In fact, if you look where it is on the board, it'll probably say F something or other. Okay, can't easily see it, but I'm sure that's what this is. I find these type of fuses with the leads soldered on the end are really useful. We can have a look at that as well in a moment. These are called XY capacitors. You find them on mains inputs. Always keep some of these in. So I've just put a bit of solder on one end, and these should just flick out of the board. Okay, they're glued together. That doesn't help, but I'll go again. Probably try to get both of them. I actually thought I had them then. If you can't get a grip, then yeah, you can't get a grip. Try something else. Okay, I've actually found something a little bit tricky to unsolder. I think it's probably the glue holding this in place. It seems to be stuck to the capacitor next to it. Now I think they'll come out. These sort of things are usually so easy to unsolder that if it's being tricky like that, there's probably a good reason for it. Yeah, look, you see, that's what I expected it to do before. Okay, we can soon unglue those. These little filter chokes, I'll keep a few of them. I've got quite a few of these. I'll take one or two off. Not only are these useful as filters, but they're a useful source of enamelled copper wire. So this, although it looks like just copper wire, is actually covered in an insulating layer, which is like a clear lacquer. You see that thing there? B1, I think that is probably an inductor bead. It's an unusual component, so I think I'll take that. So this one has 2 windings on it. It's not a transformer, it's just a dual choke basically. Filter, inductor if you like. Yeah, so you can see that's come out quite easily. And then we can go for the other end to see where the wires are. Okay, so that came off nicely. I'd say keep a few of these. High voltage capacitors, large ones, I tend to keep. Yeah, it's just come off, that has. Other end. That's coming out as well. Yeah, just again, it was the glue that was holding it in place. This, I'm pretty sure 1.0 is the value, 1 microfarad, 250 volts. K is not kilo, as in like kilo ohms, or kilo ohms, I should say. That is the tolerance, so they were sort of handy things to have. And as I mentioned, this one, okay. Yeah, this is 105. So again, that is like 1 million or 1 microfarad. K is the tolerance. Is this 250 volts as well? Yeah, so basically these two are the same rating as each other. These large ones will take. See how easily that came out? Yeah, 200 volt, 470. These are quite expensive capacitors to buy, these sort of capacitors. And they very rarely fail actually, so these are almost certainly good. And they're easy to test as well anyway. Now I've removed those, I've got these, I think these might be... I'm not sure. I thought they might have been resistors, but I don't think they are at all. Let's see. These could be some sort of voltage dependent resistor or something like that. Certainly worth having a look. If it's not unsoldering, bit of fresh solder. If it's still not unsoldering, get into the right place. Solder actually varies in quality as well, so try different sorts of solder. Again, if it's not working easily, if adding the solder isn't really helping, try a different brand of solder. So as I said, there's many good things that will come out of doing this sort of thing. Okay, high powered resistors I always take. Okay, what's this one? Well, it looks like brown, orange, brown, which would be 130 ohms. Okay, that could actually be a red. 120 is more of a standard value, but you can measure that easily. Now, heat sinks. You can either try to unsolder the heatsink with all the devices attached to it, or, as I've done, take out the components that are in your way and then take the screws out. I think this is the easy way. So we're going to do both of these by this method, okay? So by removing those, I can now get to the screws. And you can see that the screws have got like little plastic inserts in here. Can you see these things? These are to stop the metal tab of the device shorting to the heatsink. And also these special insulated washers behind, which may be pink or grey or sometimes like a clear hard material called mica. Always keep these things, always salvage them. Just, they're not very big, keep them, they're very useful. What I'll probably do with this now is remove the heat sink. So this one looks like it's actually got a screw there. It's a bit unusual. Yeah, and that one just came off, so that was screwed. If you want to keep these things really safe, just stick them back into here, because that's when you're going to want them. That's when you're going to want these things, so why not just stick them back into the heatsink now, yeah? And then they're there when you need them, okay? So those sort of things are really handy, especially this one because it has a screw mount, which is great. A little self-tapper is in here. I've got it. It's not straight, but I've got it. Now we can get these two power devices. 3 pins. We're going to use the very quick method, hit all 3 at once with some fresh solder and just pull it out the board. Okay, one's here. The other one is here. So I'll just get hold of it with my fingers. Heat all 3 pins, and it came straight off. If it doesn't do that, then either you're not using good solder or you're not using a good soldering iron. Or you're using a good soldering iron with the wrong sort of tip, okay? So guys, with a bit of practice, you should be able to do that just as fast as I'm doing it. If you can't, the chances are, once you've had some practice, that it's some other factor, okay? This thing marked D304, probably a 2SD304X. Could be a MOSFET or a transistor. Component analyzer will tell us. Here's the other one. These are normally in this place on the circuit bipolar transistors. We'll try them. They should be the same as each other. These sort of high frequency switching transformers, I don't normally bother to salvage. You can if you want to play around with these. This one has been removed. I actually used this one when I built the dot convention finder that told you the actual polarity, not really polarity, the phase of the winding. So I actually used that in the experiments. Otherwise I probably wouldn't bother. But I have seen some projects that you can build your own little switch modes with these if you want to do that sort of thing. Take them off. I'm mostly interested in the devices on here. Now what's stopping me getting to these devices in this heatsink are these basically. So this one has very long legs, so I think I'll just actually try to unsolder this one. Okay. Yeah, that came off easily enough. The other one, I think it's here or here. Probably here. Yeah. So that came out easily enough. This other choke is in the way. Now, if you want it, you can just unsolder that the same way we did the other ones. If you don't want it, then what we can just do here, literally, is to break these off the board, because we don't want them, they're faulty anyway. And then we can probably just cut the wires on this. So if you don't want it and you just want to get it out the way very quickly, well, quite literally, snip the wires. Can I even get to it still? Let's have a look. Okay. It's still in my way, but I'm sure I can actually get this off with a little bit of brute force. We'll try this method. Okay, so I'm just literally getting this out of my way in a rather destructive manner. And now I can get to the screws, okay? I can get to them anyway now. If you want to get something you really want and you're not bothered about the thing in the way, well, that's how to deal with it. This heatsink also is held on by a screw. This is quite unusual. Normally this solders. We have it. This little PCB, this is actually the fan motor control. Sometimes I keep things like this just as they are because they're interesting to use effectively as a module in some sort of project. Okay, you can generally figure out what wire is which. So this is a thermistor. This is the plus 12 volt in the ground. This must measure the temperature. It'd be quite easy to reverse engineer this to figure out how it works. This one I think goes to the fan. It says NV4 on it. I'm pretty sure that is the fan, to be honest. So you might want to keep things like this just to have a play around with them. There's our heatsink. Again with all the screws. Then there's these devices, which are what we were really looking for. These are double Schottky diodes. Yeah, you can see like the double diode symbol on them. So these we can get now. I can see where they are. One of them is here. Another good thing with this sort of salvage work, you start to recognize easily where the pins of components are on the other side of the board. Yeah, out it came very easily. Next one. Out it came. And the last one. Struggling to get to the third pin. This one wants just a little bit of extra solder adding. Okay, now it should come easily. Now it's too hot. Stick this through the hole in it. Okay. There. Inductors are generally quite expensive to buy, so I will salvage them. Just fell out the board, that one. These little trimmer pots, these are fairly easy to unsolder. They have 3 pins on them, arranged in a triangle, 1, 2, 3. If I get something underneath it, okay, solder onto the pins, and then we'll try just to hit the 3 quickly in order. Yeah, you see it came out. There's another one of these, yeah, just over here. So again, this has like a little component in the way, so I'm just gonna effectively just move that out of the way. I've just actually broken one of the leads off it because I don't want it. Okay, now I can get to my trimmer pot. I'm underneath it. So we're recognising the pattern. We're looking for 3 legs. This one looks like it's 1, 2, 3. 2 are actually connected together. Sometimes you'll find that. So we have 1, 2, 3. Yeah, out it came. Opto isolator, much the same technique. So again, we get something underneath it. Easy to spot where it is. So we have 2 pins here. You see I've managed to bridge them nicely. That make it easy. 2 more pins here. And then I can just heat up either end. Well, it fell out the board. Didn't even require any pressure, it just fell out the board, okay. And what else am I interested in? Well, there's a nice chunky diode here. Another small one here. Take the ones you want. I'm just going to take this big one. And then we have 1, 2, 3 transistors, 4, 5 transistors. So I'm definitely going to take those. This one's just glued to here, but yeah, we can soon resolve that. Right, let's get these. So I'll start with the transistors. Tweezers. I'm going to get the tweezers. I'm just actually putting them like under the transistor. I'm not trying to grab the transistor. I'm just putting the tweezers through there. Can you see? Now we need to just find out where the 3 legs are. Let's have another look. So we're in a line going that way somewhere. Ah, this looks like it here. So a bit of solder. Okay. Is that it? Yeah, it's just straight out, look, nice and clean. Another one kind of is. This is going in that direction. So again, I'm just going to push these between the legs. Sometimes I'll go like that, so either side of the middle pin. Okay. This one goes in this direction. Yeah, it's there. I can see this one quite clearly. It's one of these, 3 of these 4. A bit of fresh solder then. Okay, let's go for it. Now this one doesn't want to move, so that tells me I'm actually in the wrong place. Yeah, I think it's here. Capacitor just fell out. So I was near that capacitor. Now I can see where it is. It's here. That's why I can't get it out, because I'm in the wrong place, okay? Right, it's out. A few more. The big diode, which is there. Just hook this through it again. Okay. This has quite thick, chunky legs on, so should be able to see where it is. I think it's here somewhere. That could be one of them. That looks like a big chunky one. And maybe this one. Yeah, out it came. This board's a little bit harder to work than the other ones I've done. I'm sure you can see that. That's not just me. Some PCBs are a little bit more tricky than other ones. Sometimes it's a bit harder to find your place, or they just need a bit more heat. Sometimes it's down to the quality of the original solder as well. But this, I think now we just have a few more transistors. 1, 2, 3, 4. Okay, so I think I have pretty much what I want from this one. You may want to salvage other things. There are various little diodes and such like. I tend to have a lot of these components already, but probably because I've salvaged a lot of them already. So you may want to take more, but the technique is exactly the same that I've been using. So let's have a look to see what we have from this board. Well, we have a little stash of useful capacitors here. This one just fell out, so I'll keep it. We were looking at some of these as we desoldered them. So we have those. A couple of XY capacitors. These are a special type of capacitor used on mains filtering circuits, basically. A couple of handy high wattage resistors. Yeah, this one is a 130 ohms. This one's a 47 ohms. We have a diode, quite a chunky one, SR504. You'd be able to look this up. It's almost certainly a 5 amp and probably a 40 volt. And I would say this is a Schottky diode. Very easy to test. So if this reads about 0.15 or something similar, it's Schottky. What does it read? Well, actually, it's back to front, so it reads nothing. Go again the other way around. Yeah, 0.134. So that's a Schottky diode. Pretty sure we'll find that is 5 amp, quite nice. We have some little trimmer pots. You can see these are marked 501. That's a 500 ohm. This one's marked 102. So this is a 1 kilo ohm, 1 0 and 2 more zeros. You can measure them anyway, so if you measure the resistance across the track, we'll take this one. If we're not sure, we just measure it. Not to the wiper, because that will vary depending on the position, but across the other two. Yeah, and it's reading like 855 ohms, so that should tell you it's around 1,000 from the markings 102. This one, which I said was a... Actually, this is marked the other way. I think it's a high value one. My mistake. I think this is actually... Well, it could be 501, which is 500. Or it could be 105, which is 1 mega ohm. So let's have a look. What do we have? I'll not touch both because if it's a high value resistance. Let's see. Well, it actually reads 500k or half a mega ohm, which doesn't seem to match the reading I'm getting from it at all. But I'd say if anything, it's a 1 meg resistor. I'm not quite sure why I'm seeing that. If I had my fingers on it, that would affect the reading. I can touch one pin and not affect it. Yeah, same, so reach 500k, interesting. Then I have a few inductors, useful things. Nice to experiment with. One opto isolator, so I'm sure we could find a data sheet for that if we want to. Okay. Small diode just happened to fall out of the board. FR, that's like a fast rectifier. Again, to find a data sheet for that. We have a whole stash of small transistors. These are all saying C495, or those two are. So those are a 2SC. 2SC945, 2SC945, 2SA733. So the A's, I think, are NPN and the C's are PNP, or the other way around. That's another C. We could soon test them with an analyzer or look up the data sheet. That is a voltage reference, KIA431A. That is not a transistor, but they're handy components. And there's another 2SC. Okay, so we have a little handful of small transistors and a voltage reference there. These we can see clearly are double diodes. Okay, easily find the data sheet. And these are probably bipolar transistors. possibly a 2SD304, but we can measure them quite easily, or rather we can test them to see what they are, identify them. The ones that start with a D, like that, C and D, are usually bipolar, if not always, and the ones that start with K will be a 2SK, and they are MOSFETs. Let's see what this one actually is. Yeah, NPN silicon transistor, that's what I thought they were. These will probably be high voltage transistors, so these are very handy. They'll probably be 600 volts or something like that. I know that from where they were in the circuit. And again, these are things you can learn by doing this. And then we have these. So this one, I'm certain is a fuse. It certainly is a fuse, and we'll be able to read the rating. It's probably something like a 3 amp or 5 amp. I find these sort of fuses very handy, not so readily available to buy. I'm sure they are, but I don't have any. I have lots of fuses, and I find it difficult to solder onto the normal type. So these are very handy. Okay, 6.3 amp, you can see it there. T, 6.3 amp. So the T is effectively like a, I know it's an F. So F is a fast blow. T is like a time delay, if you like. Okay, so 6.3 amp, useful. This one said R something bright on the circuit. It makes me think it's a resistor. Yeah, I was right. It's a resistor, another 47 ohms. I managed to scratch this one a little bit when I was removing the heat shrink from it. But these are using the low voltage circuit, so it's probably okay. We can just measure it first, but that's probably okay. I know it's from a low voltage circuit because it's a low value resistor, and anyway, it was on the secondary of the power supply. Okay, these things, I'm not sure. I think these might be some sort of capacitor. Oh, let's have a look. No, maybe not. Yeah, these are just capacitors. Quite chunky legs on them though. What are they? Maybe they're not capacitors. Maybe these are VDRs or MOVs, which is basically the same thing. Okay. What is this thing? Yeah, TVR. These are like a protection device, a voltage dependent resistor if you like, or an avalanche device. So these will break down to a certain voltage. There's the other one, the same. Handy components, those. And what's left? Well, heat sinks with all the hardware, great, and expensive to buy. The little fan controller, because I know what it is, it's a handy little thing. I'll just keep that. And the same goes for things like this. So this is a power supply. This is salvaged. It came from a Humax satellite receiver. But this is a handy thing to have for me anyway. So this is 12 volt output. There's 4 wires, but you can see in fact there's only a single 12 volt voltage rail. Okay. It's working. And I have uses for these sort of power supplies. So things like this, although yes, this is salvaged, I won't salvage this for the components because it's useful to me in its own right. So things like that, and the same applies to wall warts, if you like, power packs that plug into the mains. If they're working, I keep them as working. I have boxes for 5 volt, 12 volts, and other, basically. So if they're a useful voltage and current, or if they're an unusual voltage, I will keep them. If they work, I won't actually salvage them for the parts. So that can stay as it is. What's this thing? Well, this came off a computer by the looks of it. If I want anything from this at all, well, there's a card reader, which if you want the card reader, you can just take that off there. Otherwise, there's an LED. There is some USB 3 sockets here. Will this thing easily just come apart? Yeah, maybe. So you might want the sockets off this actually. I mean, broken USBs are quite common. If we can get them easily enough, why not? The sockets are handy. They're just attached to the wires directly, so I'd probably just keep hold of that with the wires soldered on it because I can easily see what's what with it. Okay, but you can soon stick a jack plug in there and just meter through, so that sort of thing has got to be worth keeping. Okay, these USB 3, let's have a look. Again, that's a handy thing, but I'm guessing you guys want to see how we're going to unsolder this from the board. Yeah, I mean, let's not make life so easy for ourselves, so let's see if we can get this off here. Right, so the first thing I'm going to do is remove these capacitors. Not because I want them particularly, more because they're likely to explode if I don't take them off the board now. So, getting this off here. Right. First thing, flux. My flux seems to be clogged up. I could unclog it, so I could just do that. This seems to happen with this cheap flux that I get. I'm sure it's not genuine, but it does work very well. So we'll add leaded solder to all the pins on here, okay? As much as we can. Try to get onto all the pins if I can. Okay. I think that's got all of them. Now, we're going to hold this in a vise. Then we're going to warm this up from the side where I added all the solder and see if we can just take this off the board. I'll do this using my pliers. I need to get a bit of a grip on this rather than using tweezers. Let's warm it up and let's see how long it takes. And let's see if we melt it. I think it's coming. Yeah. So the capacitor I didn't need or didn't want, in fact that way because it's actually pulled the wire out of the board. This is something you should not do when you're repairing stuff, so another thing you can learn from salvaging is to not do that, okay? But seeing as I had to remove them anyway, may as well keep them. Here is our dual USB 3 socket. If it's a genuine one, let's look at the connections down in there. Yeah, seems to be enough pins on it at least. So that's the dual socket. You can see that's come off really well without melting anything. So yes, you can salvage these sort of components. That's the way to do it. What's next? Well, we have this. So this is a power supply of something. We have a lot of similar parts to that with the old ATX. In fact, this probably is a kind of an ATX power supply or something similar. Certainly 5 volt and 12 volt. Something's being removed here. Some capacitors probably weren't fitted. So this is scrap. What do we want? Well, that's a thermos, so that's useful. That's a fuse. transistor or TL431 opto isolator. There's a chip under there, we might want that. Bridge rectifier, power devices and heat sinks, of course, again. So let's see, another inductor, 22 ohm resistor, so we're getting quite a nice collection of 1 or 2 watt resistors here. I think these are probably 1 watt. Let's see how easily we can get to this lot. So probably the first thing, if we get these heat sinks off it, we can see here there's 2 devices here. There's nothing behind these capacitors. In fact, it's probably easier to get the heatsink off first. So with this one, I'll just take these screws out. Again, we have the plastic insulators on them. Screws fell in there somewhere, I'm sure we'll find it. Heatsink, so that is basically loose. Yeah, it just came off. It looks like it was soldered in, but it just fell out. Now I found the other screw. Same with this one. So we have a device here, and we have some more on the other side. You can see bad capacitors on here, which is probably what was wrong with it originally. So to get to this, I need to take quite a bit of stuff off the board. I think I might try and remove this heatsink, at least with those devices already mounted to it, rather than trying to remove too much stuff to get at it. So this one, we can take this out. Okay, the glue, yeah, we can get the glue out of the way. So here's our heatsink. Just make sure this isn't actually still really attached to it. Yeah, that's the little washer, by the way. Just get a couple things off here. Okay, came out very easily. Bit of fresh solder. Now this power device, I can get hold of it. You can see where the 3 pins are. Yeah, there. So we should be able to just melt this, and this should just come off. Yeah, it's coming loose. It's off. Okay. There's a couple of little transistors down here. I think I'll just get these while I'm here. See, that just fell out. Try this one. There's quite a few service mount components in the way, but I'm not going to worry about them. I'm going to go straight over them. Okay. This might be getting a bit warm. So I'll get hold of the legs, not the body, the legs, just loosely. I'm not squeezing hard on them. Yeah, out it came. This one. That's out of our way. Now I can see the heat sink is held on by a pin there. And then of course the devices are attached to it. How easily can I get down to this thing? Well, the main thing in the way is that. So I might be able to actually unsolder this. If it's going to give me too much trouble, then we'll go another way, but let's see. So couple of pins there, and then a whole row of them on the other side. To do this, you think you probably need braid or a desoldering tool, and that may well be the case, but if we're not too worried about the PCB, we just want to get it off, and we're not too worried about the device for that matter, because I want what's behind it. Let's have a go. So pressure on here. Hit these two. Can I move it? Yeah, you see I moved it. Okay, now can we move it more? So try these ones. No. Try these ones. Yeah, I think I've moved that by bending the PCB. Okay, let's go the other way. Get pressure. Back to this side again. Yeah. A little bit of brute force. Okay. Try down here. I felt it move. This is going to come out. Yeah. So there's one more lead attached to it, which is here. Right. So you can see actually, although that looked like really nasty, that actually came out really well. Whether it was quicker than using the soldering braid, not sure, but there it is. And now we can get to what we want. Okay, so I've unbolted the devices. There's a leg, we can see the leg here. That's coming out. And this will probably have one at the other end somewhere. Yeah, I can see it. It's down in here somewhere. That ends out. Okay. Now these power transistors and diodes will come out very easily. Okay, so getting there now with this. These were obviously bad capacitors. Resistor, I'm going to take that one. And a few transistors and the bridge rectifier. Okay, so the bridge, and this is the thermistor that I want. There's a fuse there. Something here, what's that? Well, it's got a hole burnt in it, whatever it is. Yeah. That looks like what's left of a controller chip. Can you see it? All burnt and blackened. I think the lid's even come off it. So we can sort of see why this thing was scrap. Yeah, that's interesting. You can see the bottom of it. Let's get under the microscope. If I just clean it a little bit, just to see what we have. Yeah, wow guys, look at that. Yeah, so you can see how that failed. That is what's left of the pulse width modulator, which would have a built-in MOSFET. Yeah, look at that. Wow. Stunning. I don't think that works. Okay. Because that is so badly destroyed, I'm not going to bother with things like the opto around here. I mean, that's the TL431, which is on the low voltage side. I've got a lot of them, so I'm not going to bother with it. I'm not going to generally bother with the stuff around here at all on the high voltage side, just because of what's happened. That may well mean that some of the transistors I removed from this are also faulty, so I think I'll actually check them. And the bridge rectifier. So before I unsolder this, I'm just going to check to see if it's actually any good. So with the red lead on the 2 AC, we should have a diode junction to one end, but not the other end. Okay. And then with the black lead onto the AC, we should have a connection to the other end. Yes. Yeah, so that does read like a good bridge rectifier. This should read open in one direction and kind of like 2 diodes, yeah, 0.9 in the other direction. So that actually reads okay. So you could take that if you want. Because of the damage of what's happened here, I'm actually not going to bother. But that's mainly because I've got so many of them. It reads okay, so feel quite happy to take that if you want. The same with these capacitors. Personally, because of what I've seen down there, I'm actually not going to bother with the rest of it. Same with this low value resistor down here. It's probably being distressed, shall we say, due to the way that this failed. So what did we get? Well, heat sinks, they'll be fine. Inductors, they'll be fine. High voltage capacitor, these won't fail, I wouldn't have thought, not easily anyway. In that sort of way at least. This is the NTC. This could well have gone open circuit because all the power runs through here. The same with the fuse. So if it reads like a low value resistor, probably okay. Yeah, that's what you'd expect it to read like. Fuse. Reads okay. Resistors, this one 5-1 and no zeros. This is a 51 ohm. Reads okay. This one is a 22 ohm. This is actually damaged there. That may be when I took it out of the circuit. Reads okay though, and this won't be in a high voltage position, so that again I wouldn't worry about it. If they're low value, they're not going to be in high voltage circuits. And then we have some semiconductor devices, so let's just check these. The transformer came off nice and clean, by the way. I don't really need it though. These I will check before I even decide to keep them. I mean, it looks like that chip was probably the standby that blew up on that power supply, not the main supply rail. Yeah, that's, now it says digital transistor. This would be a transistor with with a resistor in the base circuit built in, but I'm not trusting it. Okay, because you wouldn't have what's called a digital transistor in this sort of circuit. So I'm just going to bin that. This one. That says germanium transistor. It's not going to be as germanium, so I'm not going to trust that either. Go with the bin. These things. Yeah, that says it's a diode network. That may well be the case. Let's look at the markings on it. Yeah, that is in fact a diode network. We can see there, like there's like a double diode symbol. Okay, that's fine. This one's also a double diode. So these are on the secondary, so there's no real reason to expect these will be faulty. Yeah. And then we have these three. This is another diode network. You can see the symbol quite clearly. Okay. These will be MOSFETs or transistors. What's the marking? 13007. I think that is a NPN transistor. But that's just a thing. Let's have a look. Yeah, thought it was. So high voltage transistor again, quite handy ones. Often find these in power supplies. And another one. I've had to order these in the past to repair things, and we can say we know these are original because what's exploded appears to be on the standby side. I'm not too unhappy about keeping these. That one says common anode network. Could just be a bad connection. Let's go again. Yeah, If one of these is gone, I'm not going to trust the other one either. And bear in mind, these came off the high voltage side, I think all of them did. Yeah. Guys, if you find that, just bin both of them, okay? It's not worth the hassle. So guys, that's it for this video. I actually have some more stuff I can salvage that's lying around. This I was given. This is a AV receiver amplifier. I don't know if this works or doesn't, but basically this is all like standard definition video. It's not HDMI. I don't have the speakers that go with it anyway, so I don't see any reason I should keep this other than it's probably full of useful parts. I was given that for free by the guy on the car boot sale that I buy a lot of my computers off. I have an old Apple power supply that we tried to repair that exploded again. Maybe some useful bits on there. I have this, looks like some sort of possibly an amplifier module. I have this thing, some sort of relay driver. And I have an old Gigabyte motherboard that's dead, faulty, PCH. So I think there's more to learn here, but this is down to you guys now. Have you seen enough, Rich? Hey Rich, I've had enough of that. Or would you like to go one more time and let's see what we can salvage from here, and let's see if we can learn any more useful techniques? Let me know in the comments below. Depending on how that goes, you will or will not see a bit more. Okay guys, hope you enjoyed that. I hope forward to seeing you again on Learning Electronics Repair. Ciao for now guys.